I'm going to perform a demonstration on inquarting some Karat gold. I have a mixture here of equal parts of 10 karat and 14 karat gold, so I have 26 grams of 10 karat and 26 grams of 14 karat gold in this bag. I've also added in 54 grams of sterling silver. The sterling silver weight equals the weight of the equivalent 12 karat gold. So what I'll do is I'll take a prepared melting dish that's in the mini fire brick furnace, just the bottom half. I have some handle locks for picking up the dish and dumping it into the corn flaking water, the stainless steel dish with cold water in it. And I have my igniter, my torch, and my safety gloves. First step is I'll add all my metals into the dish and begin heating to melt it into one continuous alloy. I got all the scrap in the dish, now I'm going to start heating. You may see a little smoke as the garbage burns off of this jewelry. The idea here is just to melt the silver and gold into a consistent mass. With a matte gas torch, it's going to take a little time. You could use acetylene to speed it up, but the matte will work since when you mix the gold and the silver, the alloy actually melts at a lower temperature than it normally would. We want to try to get some of the silver molten so that it absorbs the gold a lot easier. If you have molten silver, the gold will tend to want to soak into it a lot simpler than just trying to melt the gold and then add the silver in. This prepared dish should allow the silver and the gold to all soak down to the bottom as it melts also. You tell the items that are gold because they don't melt nearly as easy on their own. We just work our way around the dish. As the silver becomes molten in the bottom of the dish, it starts to absorb the gold into it. And if I pull away the torch, you can see the silver looks all shiny in here. When I pull the torch away, it turns into that kind of a off gold color, almost brassy looking. That's a sign that it is combining with the gold, and we know we're making a good alloy. Generally speaking, you want to get this bottom full of the silver molten, and as you heat that molten silver and bring the gold to its surface, it'll absorb the gold. We just sit here and work the gold down into the silver. And we just work our way around the dish, forming the alloy we need for inquarting. Inquarting is 75% silver or other base metals, 25% gold. You can see now that it's getting pretty molten. The slag on top still floats upon the button at the bottom, so we still got to work this slag down in it. You don't want to stop until you have all of this into that molten pile. You see how it's molten on the bottom. Every bit of this should combine and make one consistent alloy. You won't be able to pour it into the water until you get it all molten and moving freely like that underneath there is. And you can also see it's taking on even a gold color now, even while it's hot. You don't want to stop until you get all of this metal material in the slag melted into the larger button underneath. It should all be molten like that is underneath there. Now once you've got this below the top surface level of this dish, you can go ahead and set up your mini fire brick and finish it up with the fire brick and just allow it to become molten at this point. This last stage here tends to take a little longer if you don't use the top, because it has a lot of gold still on top. The button on the bottom is getting to be a higher temperature alloy, so it takes more heat to keep it molten, and that's why it takes longer at the last stage. I would recommend definitely closing up the mini fire brick at this point. So far I've been working about 20 minutes on this. You can cut at least 10 minutes off the time if you close the top of the fire. You've got the alloy molten and the slag off the top pretty much melted. I'm going to take a small bit of borax, sprinkle it on top just to make sure you don't have any gold left in that slag. The borax will kind of move the slag to the side, and the gold will combine with the inquarted alloy at the bottom. With approximately 6 karat gold now, 75% silver or any other base metal you choose. I choose silver because it takes less nitric acid to dissolve it in the next step, and it's 25% bullion gold. We're going to pour it into the dish of cold water in a circular motion. Make sure you get it all molten. It may take a couple of heatings. You want to keep the torch on it the whole time. You want to get above the dish. We're going to pour the molten gold into the cold water. This is making your cornflakes. If it gets stuck, just heat it up, let it drop off. To work all this gold out. Now that you've poured the alloy into the water, it's formed these flat, spread out type pieces called cornflakes. This dissolves very easily in 35% nitric acid, leaving behind a mossy type brown powder or sponge. That's your gold. Your silver will be in your solution. You want to be sure you use distilled water when you dilute your nitric acid. And that's how you inquart the cornflakes after they've been taken out of the water. They could vary anywhere in color from silvery gold to almost yellow gold, like you see here. The calculation you use if you used silver is 1.7 milliliters of 70% nitric acid per gram of silver. You can watch the dissolution process and the mixing of the nitric in the water in my other silver video called Separating Silver and Gold.